Welcome to our on-demand video series for SQL Server in Azure. I'm TJ Turner, one of the Microsoft Cloud sales engineers here at Synix. And today we're going to be focusing on the choices and costs that need to be considered when looking at SQL Server for Azure. First, we're going to look at why you would want to move SQL to Azure. And there's a bunch of reasons. First off, you might want to migrate and modernize based on your need to upgrade an application, replace aging hardware, keep up with the latest regulatory and industry security and compliance standards, avoid end of support, or modernize your business applications with new technology to better serve customers and your internal employees or partners. Whatever that motivation may be, both small and medium businesses can benefit from this overall total cost of ownership, improvement in total cost of ownership and security, compliance, certifications, and innovative database services that you can take advantage of in Azure Cloud. With the Azure pay-as-you-go pricing, you pay by the minute, so you only pay for what you use. So when your business is growing rapidly, quickly, you can spin up new servers. During slow times, you can spin them back down. Or for stable long-term workload, you can purchase SQL Server subscriptions and get reserved capacity pricing to lock in some of your better rates. This helps you manage your cost and keep track of your ROI. One thing Microsoft is really focused on is the security and availability of your instances. The cloud, and the question that you kind of ask is, well, can I be more secure in on-prem versus in the cloud? And there's a big question around that. So Microsoft, for instance, spends $1 billion annually and has a team of 3,500 security specialists dedicated to fighting security attacks. So why not put them to work and safeguard your business? Also, moving to the cloud is be able to add innovation at your own pace. Running SQL Server workloads on-premise and in the cloud, so you can hybrid on both. So you can run in on-premise and in the cloud to be able to take advantage of the features that Azure Cloud provides. You can also streamline your IT resources and open yourself for being able to spend focus time on the things that are important for you and your business. You can operate the server and storage infrastructure and let Azure do that so you can focus on the apps and the data and the things and the features that you need to build within your practice. Again, we kind of touch on the best in ROI. You're going to be able to take advantage, especially with the database managed instance, which is going to closely full parity, 100% code consistency across SQL, back to SQL Server to 2005. You can get high ROI. You can get Microsoft incentives, especially as a partner. And then you can migrate and use licensing that you currently already have within Azure and on-prem and be able to make that shift to make it more cost effective for you to get everything up into Azure and be able to leverage that. The other things that they have is intelligent database, SQL database breakthrough productivity and performance. They meet the demands of today's apps with dynamic scalability. It's a very difficult thing to do on premise without a big capital expenditure, and Azure allows you to do that very easily and quickly. Intelligent protection, again, we go back to security, and that Microsoft spends a lot of effort to make sure that your information is secure within Azure, and it's protected as well. SQL databases also have built-in intelligence that helps customers dramatically reduce the cost of running and managing the databases and maximizes both performance and security with encryption and other features that are built in. You can be in a hybrid environment, as we alluded to earlier, where you can run in both places, either on-prem and in Azure, so that you can mitigate your risk as you move into the Azure workspace. Azure SQL database managed instances also make it really easy for you to migrate into SQL, or Azure SQL, as you can just do a backup and restore, backup from your on-premise database and restore to the managed instance that you have set up. And there's tools to help you do that. Some of those tools are here. As we assess, you can get the database migration tool set and guide that Microsoft's provided to allow you to assess your environment, assess your database, and build what may look. So you could have that option. Do I need to go to a managed instance? Do I need to go to Azure SQL database? Or am I going to have to run in a third variation of a VM running SQL in Azure? Migrate using the backup and restore to a managed instance. This is a hybrid model as well, along with being able to migrate from one to the other. And Microsoft has a lot of tools that can provide help and assistance in that. It's easy to get started in Azure. You can rely on us as a partner. We can help you and guide you along the way as you start to grow in this practice. For assessments, customers can inventory their workloads and map them to the right size of SQL as well to help with their costing. SQL Server or virtual machines using the free assessment tool with Azure Migrate. Customers can rehost databases within a few to no code changes. Microsoft's provided some really good ways of being able to assess and migrate and then even optimize to help you make sure that you're getting the best cost management and security for your workloads. So what are our options there in Azure if we wanted to do SQL? There's three main options in SQL Server on Azure VMs, which is like running like you have on-premise today. So if you wanted to mitigate your most risk, you can do that and migrate your SQL servers just like you would on-premise if you're running VMs or running bare metal hardware as well. You can manage and run in Azure, matching up with the CPU count and memory count and all the things that you would want. The biggest thing with that, again, is what part of the machine are you managing? Here in blue, you can see that you manage applications, data, the database, the instance level features, high availability, DR, backups, the provisioning, and the operating system. You don't manage the hardware, the virtualization part, or the data center. That's all what Microsoft manages. However, if you move into the platform as a service features, whereas in SQL database managed instance, all you're handling are the SQL instant level features, database, data, and applications. You don't have to worry about your DR, your database provisioning, their operating handles all of that. And again, going into the SQL database, and the other platform offering with SQL database is now you don't even have to manage the SQL instant level features. You just manage the applications that connect to it, the data, and the database. Here's a bit more granular control of granular comparison to what's available in these three options. You have a full SQL Server set up on the Azure VM, and you can manage backups and things of that sort. And if you have some special level features or controls that you need to have, that could be your option, your only option. But if you move into the database, the SQL database managed instance, now you can go into that vCore model of base compute pricing. So that, and we'll go over that here in a minute. Then you go over to Azure SQL Database and you get another option of DTUs. What's a DTU? Well, we'll talk about what a DTU is, but it's another measurement of how Microsoft you can buy the SQL databases. And there's a lot of things in here that are different and the same and all of these things. Microsoft tries to provide on the SQL level side really consistency across the board and helping you migrate into whatever fits your model and what you need as an organization for either your application or reason to run a SQL database. Other things that are available in here too is security. Again, Microsoft takes some really important security steps that when you're in the platform as a service with the database managed instance and the SQL database, Azure SQL database, you have a lot more security features that are available because Microsoft is taking care of that security side as part of their platform. You also get threat protection, threat detection as you move through some of this stack. There's only so much that can be done on the Azure VMs because you're managing everything on that machine, whereas on the managed instance side and the SQL database side, Microsoft can watch and have machine learning to see what is normal and what's outside of the bounds of normal as well. So what are our purchasing models? We saw the one and the difference between the three of them, right, which is the VM. So we understand how to buy VMs, and we can understand how to buy VMs based on the number of CPUs and running what it takes to run that VM. And you can look at the Azure pricing calculator to get the costing for what it's going to take to run an Azure VM. But for the other two options, there's two potentials. Now, if you're running the managed instance, all you have available to you is vCore. But if you're going to run an Azure SQL database, you have this DTU option. Well, what's the difference between the DTU? So DTUs are essentially made simple, pre-configured that kind of combine memory and compute and storage transactions all into one measurable unit, aka the DTU. And these are usually best for the customers who just want simple, pre-configured resources. Their applications don't really run outside of the bounds of what's considered normal use. And there's levels within DTUs that you can match up. The vCore model gives you a bit more flexibility, a bit more transparency, a bit more control, and kind of what we're used to when we provision even VMs. So as you can kind of see, the resources that you provision there are always there for your workloads. On the DTU side, those resources are available for you there too. However, if you hit the thresholds of those resources, you'll start to be throttled, resulting in slower performance and timeouts. So what's the definition of a DTU? A DTU is a database transaction unit is a blend of measure of CPU, memory, data I/O, and transaction log I/O in a ratio with the online transactional benchmark workload that Microsoft has defined. Microsoft's also provided a DTU calculator to kind of help with this process because it's looking at a lot of different performances from a SQL database. And it's very helpful to have this calculator so that you can then run this. And basically what it does is runs a PowerShell command that collects some performance statistics, generates a CSV file that has processor time, percentage of processor time, total disk reads a second, total writes a second, and log bytes flushed a second. And what it all does is it spits that out. And on the website there, you import the CSV and you kind of tell it how many cores, and then you'll get the calculator is going to tell you where you should fit. The other part for the DTU calculator does not isolate a single database. And with that in mind, means that you're going to have to do a few things if you're running multiple databases on a single server. So how is a DTU determined? To determine the average percentage of a DTU, it's basically uses the calculation, the average DTU percent equals the max CPU, average data, and I/O percentage. One thing to note as you look through this, and before we kind of get into where these stats really come from, the DTU limit of a database is determined by the CPU, its reads, its writes, its memory that's available to the database. However, because the SQL database engine typically uses all of its available memory for its data cache to improve the performance, the average memory used percentage value will usually be close to 100%, regardless of the database load. Therefore, even though memory does indirectly influence the DTU limit, it's not used in the DTU utilization formula. And that's because it's most often going to be close to 100%, which is why in the calculator, it's not part of the overall calculation that's sent back because it's assumed that it's going to use all of the memory that is available to it. So here we go and grab the stats from our database resource stats, system resource stats, and elastic pool resource stats. And you can look through where these average CPU percentages are, average data I/O percentage, and log write percentages. We'll give you that calculation if you want to go and look. So what does it mean? Like if we try to map these DTUs to a traditional hardware, then these first couple are really like they're really for low key basic type things and are really probably not going to be enough to run a regular workload. If you look at the IOPS, it's like 10 IOPS, 150 IOPS, which isn't very much at all. As we get to this 1 core, 2 to 3 cores, and these tiers, this premium P11, this premium P15, and they do, they change to the DS4, which is, I believe, an 8-core box and a 16-core box with the 5. Those are how they try to correlate. Now, this is an estimation, it's not exact, but this is what we try to put together so that we can kind of get some correlation as to what we need to do as a DTU. Now, the beauty of this is Microsoft does provide a mechanism that if you hit certain DTU thresholds, it might make sense to go into the vCore model. And so in summary here, the difference with DTUs and vCore, obviously DTUs are calculated value. And if you know your workload and you can track your workload performance, then you need to know you'll know if a DTU makes sense for you or not. And it's a way of being able to help make sure that you have the resources available, but also are able to take advantage of some cost savings and making sure that you're not, make sure that the costing for your machines don't get out of control. But if you need to move into the vCore, there's a migration workload with zero downtime to move into a vCore model. So a DTU, it guarantees a certain level of resources for the database. And this is kind of a predictable level of performance, what Microsoft kind of expects, and in those levels you can adjust. But they're available to you, and it's based off of a measure of compute and storage and I/O. But if your workload exceeds any amount of those resources, then your throughput is throttled, resulting in slower performance and timeout. So that's the caveat with the DTU. On the vCore, it's kind of what we're used to when we provision a VM, right? We know how many CPUs we need to allocate. We know how much memory we need to allocate. And it's the same thing under the vCore model. It lets you independently choose all your compute and storage resources, matching on-premise performance. So if you want that, that flexibility and the safety to know that this is what we get on-premise, this is what we know our performance is, and we want to match that in the cloud, so that way you're limiting your risk within that vCore model. So you get your compute resources, and then and like I said here at the very bottom, if your database consumes more than 300 DTUs, maybe converting to the vCore might be the right way to go. And there's processes and procedures to doing that. Understanding what your workloads are and how simple or complex or what your needs may be, we can go back and look at what these models might mean and what you might need to be in and what it may be in the phase that you look at. But costing is important. So initially you might want to go on that Azure VM just to get yourself up into the cloud, but then you want to move very quickly into some of these managed instances. And that can help because Microsoft allows and has tools that allow for you to do that. And again, helping you get that cost down, because running the Azure VM can be expensive versus running it against a managed instance or even an Azure SQL database. But we also want to understand where it makes sense from a cost standpoint for you to be, and making sure that you're getting the best bang for your buck as you move into Azure and Azure SQL. Once again, I'd like to thank you for joining our on-demand video series on Azure SQL Server, with our focus today on options and costing.